Let us look at something very interesting here. As you can see, this is a snapshot of game Tetris. I used to love playing this game, and I'm sure you must have also played this game at some point of time or seen or heard about this game, right? So we are going to explore the fascinating world of polygons using this example. Now, in the game of Tetris, there are a lot many blocks, some of which are convex, for example, this one, and some of these are concave, for example, this one. Now, the question is, what makes a polygon convex and what makes a polygon concave? Let us look into it. I am going to start by taking one example of convex polygon and one example of concave polygon. A polygon is a shape which is made up of straight lines. So let us look at these lines and at the points where the lines meet, that is the vertices. We'll notice that in the case of convex, each of the vertices is bulging outwards. Whereas in the concave polygon, we find some vertices which are bulging outwards, but then there is this one vertex which is not bulging outwards, rather it is caving in, and therefore the name concave. So if we look at a polygon and find any one vertex which is caving in, we can call it a concave polygon. Let us look at some more examples. This classification of convex and concave is done on the basis of measurement of interior angles. Now when I say interior angles, I am referring to the angles which lie within the boundary of the polygon. Let me just name this polygon as ABC. Now over here, angle A, B and C, these are the interior angles. And we can see that all of these angles are less than 180 degrees. So in a convex polygon, each interior angle is less than 180 degrees. Let's look at the concave side. Let me first name this polygon as ABCD polygon. Over here, angle A, B and D are less than 180 degrees. But let us now look at angle C. Let me draw a straight line here. Now this angle would be 180 degrees. A straight line makes 180 degrees, right? So this angle C goes beyond that. So clearly angle C is greater than 180 degrees. So we can say that in a concave polygon, at least one interior angle is greater than 180 degrees. Let us look at some more examples and now talk about diagonals. Let me just first name this polygon A, B, C, D. Now what is a diagonal? If I want to draw a diagonal from vertex A, I will leave the adjacent vertices B and D and connect it to all the other vertices available, which in this case is C only. So here is one diagonal AC and another diagonal BD. Let us draw diagonals in this polygon as well. Now we observe that in the case of convex, all the diagonals lie inside the polygon. Let's look at the concave side and draw the diagonals. Now just look over here. If I connect this vertex to this vertex, this diagonal lies outside the polygon. Similarly, let us draw some diagonals in the next polygon as well. Again, over here we find one diagonal which lies outside the polygon. So we can say that in a concave polygon, at least one diagonal lies outside the polygon. There can be more than one, but there has to be one diagonal which lies outside the polygon.